Hi, everybody. Sorry I'm a little late today. Hope everybody's having a good morning. My name is Odessky, and my official title is I'm a product manager for Orange, which is which is France Telecom, and I run a project there called DocPal here in the Bay Area, and I'm here to talk a little bit about the project as well as some of the thoughts that went into creating the project. So let's first talk about augmented reality surgery. When we first started taking a look at the AR space and seeing what kind of benefits augmented reality can bring into healthcare, surgery is the instant thing that popped into our minds. Wouldn't it be cool if we can have a mobile phone pointed at somebody's body in an emergency situation, like with a paramedic seeing somebody, and essentially having the camera recognize the wound and automatically create the most appropriate animations to perform the surgery in an emergency situation so that the person can come home alive. And there's lots of, actually, as we kind of research the space more, there's lots of extremely cool companies, particularly in Scandinavia, that are doing this stuff. And there's actually a separate conference dedicated to this in Newport Beach every year. It combines virtual reality and augmented reality together as kind of refining and innovating on how surgical procedures can both be, could doctors be both educated in these procedures as well as how these procedures can be performed in real time. So just wanted to say we're not doing any of that stuff because that was, when we looked at it, it seemed really, really complicated. And so what we decided to take a look at more specifically is how augmented reality can be used in health communications. So it's no secret today, and you guys have probably heard about this as well, is that particularly the US healthcare system is very messed up. It's about 16% of our GDP, taking something like $2.6 trillion. More than a third of it is waste, and a lot of the waste actually comes in both in terms of the paperwork and the workflow and the process of treating patients, as well as the actual frustrations that the patients feel and the creative mentality of avoidance, so they don't see the doctor in the first place, and they wait until their disease gets worse, and it's obviously when it gets worse, it's more expensive to actually maintain and cure. And so some of the statistics that are pretty prominent today is that, with the patient frustration point, it takes about 2 weeks to a month to get an appointment with a doctor in major metropolitan areas. And once you do get an appointment, there's a lot of hassle involved in coming to the office, having the problem of actually checking in, putting all entering all your information, waiting in a waiting room, and then you maybe have a 5 to 10 minute conversation. So it kind of feels like a ride in an amusement park where you wait for an hour or more than an hour, and then maybe to have a five-minute ride, which is not very thrilling. And the doctors obviously are concerned about this as well, because in the short amount of time that they have to spend with the patient, they may not necessarily have enough time to come up with the correct diagnosis, to communicate to the patient clearly about the specific procedures and the tests that they have to do, to ensure that the patient is performing the procedures properly and is following up properly. And there's not a great amount of feedback and follow-up that occurs. Maybe patients get like a sheet of paper saying, here are the exercises that you have to do, or here are the medications that you have to take, but there's no real kind of proactive follow-up that occurs. And so when we kind of thought about how we can use augmented reality in healthcare, we focused on improving the doctor-patient experience. And the way that we decided to approach that problem is to essentially create a platform from natural user interactions so that the doctor doesn't always have to be involved in gathering data from the patient, as well as having that constant conversation. So what we decided to do was combine those old school IVR experiences that you have on the phone with augmented reality. So we built a platform to essentially combine speech recognition, an avatar that kind of leads the patient through the necessary conversation, augmented reality, gestures, as well as video. So in case the patient does need to talk to somebody, they can always get on a video call from their home. And so with regards to AR, it's essentially a conversation that the patient has either on their computer screen or on their television. And the conversation, the avatar can ask them questions, as well as they can ask them to perform some very basic movements and exercises. And the way we're using AR in this case is that we're looking at the patient on camera. We're able to see the patient's body and recognize the patient's body. We use Microsoft Connect as well as the ASUS device that's also coming to market. And we're able to essentially draw on the patient animations, educating them and teaching them how to do exercises properly. And so with these kind of animations, the patients can follow along with the exercise. It can be animated. We can measure their angle of motion. And we can basically capture the exercises the patient is doing, either record them or just measure the actual angles and exercises, and then send them back to the physician for analysis. The other part of AR that we're using is perform some very basic body recognition. So if the patient has any sort of ailment on their body that they would like to indicate, they can just point at it with their hand. And we recognize where they point to. We're able to highlight the part of the body that they're pointing to. And we're also able, based on that part of the body, then we know that what the part of the body is, we're also able to ask the patient specific questions about that ailment. So it's kind of like a decision tree as you go down for a specific body part. And as the patient is basically saying these things, we can do a pop-up of their answers that's attached to the specific body part, so the patient can clearly see whether or not the answers that they're contributing to the conversation are relevant, or they can correct them as well. So we take basically what the patient has submitted to the system, and then we create this graphical animation for the doctor as well. So when the doctor finally gets the call, or they get some kind of a chart, basically, saying what the patient has said, they also get like a very nice annotated body that basically describes the patient's symptoms and like what the conditions are. And so the last thing that we've done with augmented reality is put in some simple interactivity for the patient. So it could be that they're doing exercises, they need to reach up or across or down. It could be that we can put like some markers on the top so we can test their ranges of motion, or if we want them to basically select from a list of things that they're saying, do you have condition A, condition B, or condition C? All they have to do is kind of raise their arm in the right direction and be able to select the condition. So the idea is to make this conversation combine speech recognition for things that are easy to recognize, but also have augmented reality and gesture recognition for things that are really intuitive for the patient to basically specify. And so here's our kind of initial demo result that we built a little bit while back that kind of describes what the platform can do for the case where the patient's at home, they have a condition that they want to report to the doctor, and they basically go on their television to an application in order to report that condition.
And welcome to DocPal. If you are calling for a medical emergency, or if you experience one, say call 911. Please state your name and then repeat the phrase, an apple a day.
Dana Craig, an apple a day.
Dana, your previous address and billing information are highlighted. If the information has changed, please say, my information has changed, and I will connect you with our staff. First, I need to take your blood pressure. I sense your blood pressure cuff is ready. Please work as demonstrated on screen and press the power button as shown. Your blood pressure is 125/80. I will now ask you to perform 2 range of motion tests using your right arm. With your arm, make the same movement as the on-screen animation. Stop if you feel pain or disabling discomfort. Return your arm to its resting position. Your observed range of motion has improved by 14 degrees since your last appointment. Dana, do you have any other health issues? If so, say I have a new health issue.
I have a new health issue.
Please point to the new ailment area. What's wrong with your shoulder?
I have a pretty bad rash.
Please describe your rash by repeating the following word that best applies. Mild, moderate, or severe.
Severe. It's pretty bad.
Have you started taking any medications, or do you have known allergies?
No new medications, but I'm allergic to penicillin and sulfa drugs.
You will soon be transferred to a specialist. Your wait time may last about a minute.
So after this, and a lot of the parts in the conversation were actually cut out just to make the video a little shorter, but essentially there's more data that's collected from the patient, and after all that data is collected, then we send that data to a decision support system that produces some recommended diagnoses, and then we transfer this patient, Dana, to a video call with a physician. And when the physician gets the call, they basically see this annotated body that kind of has all the test results and the ailments, as well as a recommended diagnoses, so to help the doctor have the conversation with the patient in order to resolve their issues much quicker. And we actually work with Zagara to implement the initial demo right there, so thanks a lot. And so essentially this is just one example of what the platform can do, but what we built is this platform called Sensely, and it's essentially an API that allows web developers that work in hospitals as well as healthcare companies to develop their own custom conversations that they want to have with their patients. So there's lots of different use cases for the conversations that you want to have. Triage is just one of those cases. But essentially it's a set of services that includes speech recognition, augmented reality for these basic tasks that I just talked about, avatar, a customizable avatar with text-to-speech, gesture recognition and recording. And then we've also integrated video telephony adapter so that the video call can be made. And so the idea is that the web developer, just using JavaScript APIs, can script their own custom conversation. And the kind of demand that we've seen in the healthcare industry around this particular case is in several applications, although this list keeps on growing, and so we kind of have to manage our own time and what we support. But the biggest demand has come into in the rehabilitation space. So just the very basic case that you saw of just the patient moving their arm and get their angles of motion measured, we can actually do on any sort of limb. It could be their legs, it could be their knees or their feet. And we can measure that and report it back to the physician. So literally, you can develop your own custom rehabilitation scenario for whatever ailment that the patient has at the time. Also, behavioral health has been kind of a very interesting market for us, particularly around the continuous management of addictions and school stress and things like that. Where patients have to check in at every day or every other day to basically report on how they're doing. So in the industry today, there's not enough psychologists or school counselors to be able to manage every single person that has stress or has issues. And this system kind of helps the person check in from their home or from their office and manage that kind of stuff. Triage, as I showed in the demo, is one important one. Health education as well, kind of more interactive education where kids or adults are basically shown diseases, and they learn about diseases through the use of augmented reality, through the use of gaming, to understand, okay, like what does each body part do, what is the function of each organ, that kind of thing. It's also, we're seeing a lot of demand for that, as well as basic customer service for healthcare organizations. So if you have a question for your healthcare insurer, for your hospital, you basically log into the system and essentially talk with an automated avatar. It asks you a question and tries to figure out exactly who the right person in the organization you need to talk to. So that's all I have. Thank you very much.
Dermatology image for the rash. I mean, an image is worth 1,000 words. Most dermatologists see the rash, and really care. I mean, you'll ask a couple questions, but really, the money is the
right.
Is the rash, how it looks, and how it behaves.
So the platform does have an ability. You didn't see it in the demo, but what we can do is we can actually zoom in on the body part as soon as the person highlights, and we can actually ask them to, we can take a picture of it, essentially, and we can basically send that picture to the physician. And so the platform can be scripted to just say, okay, I want to zoom in. This is the body part I'm interested in. Zoom in on that body part, take a picture of it. And for dermatology, you're right, that'll make a big impact.
Is there any implementation of quality of service in your platform, or QoS is outside?
So we work with different video conferencing providers. So obviously in Orange, there's this very large video conferencing network that we can plug into. Typically, as we work with hospitals and stuff, they already have existing telemedicine deployments, just pure video to video. And all we do is we take this pre-screening platform and we plug that into their existing video conferencing environment. With regards to this specific platform, Right now we're in private beta, so I can't really speak into the greatness of its scalability at this point in time. Maybe like in a few months I will. But it is running in the cloud, so you can essentially, in your application, you can import the necessary libraries and then start kind of scripting your own conversation.
Due to some of the limited features of the Connect, how do you kind of compensate for, like, say, things that are below, or if someone's like, I have,
Right.
you know,
Right, that's actually a very interesting question, one that we ran up against. So there are definitely things, like you said, on the upper body, there's a much greater accuracy, particularly measuring angle of motion on the lower body, and if you're sitting on a chair or if you're laying down, that you're not. So there's two ways that we're solving this problem. One way is that we're actually using additional devices for rehabilitation, so you can have like a accelerometer-based strap, like on your knees or on your legs, that also does the measurement, and then we basically correlate the data with the data that we receive to try to get the most accurate amount of data. The other one, we're actually working on creating our own, for these specific cases, like if you're sitting in a chair, we're actually creating our own, what are they called, detection algorithms that Connect doesn't provide by default. Like, so.
Any more questions? All right, well, thank you, guys.
Thank you.